Hello, welcome back to my channel. In this video, we're going to be drawing alkanes. The first question here says to draw the structural formula of the following and rename where applicable. So the first compound here is 4-ethyl-2,2-dimethyl-3-propyl-heptane. So when we are asked to draw the structural formula, the first thing we need to look at is the parent carbon here. Okay, so this gives us an idea of how long the chain will be. So now we know it's heptane, and hept represents 7. So the first thing is to write out all the 7 carbon. 1, 2, 3, 4, 5, 6, 7. Okay, now that we've done this, we then need to attach all the substituents. Now the first substituent here is a 4-ethyl. If we count this 1, 2, 3, 4, we add our ethyl here. The next one is 2,2-dimethyl. On the second carbon, there is 2 methyl groups. Okay, and on the third carbon, which is this, there is a propyl group. Propyl is 3 carbons. So you have this. Now, after attaching all the substituent, the next thing we need to do is to then fill in our hydrogens, making sure that carbon has 4 bonds complete. Okay, so here you have 1 bond, carbon to carbon, remaining 3 bonds. So we fill in 3 hydrogens, and of course one of those bonds. Now this other one has a bond to this, and it's filled up with all of this surrounding it. So we do not need to put any hydrogen there. Here we have this bond going here, 1, another one, 2, then 3. So it needs just 1 hydrogen to be complete, and of course that bond. Now we have 1 bond here, 1 here, and then another one here, remaining 1, which is hydrogen plus that bond makes it 4. And then we have 1 here, another one to this other carbon, remaining 2. So you put in your 2 hydrogens and that bond. There's a bond here and there is a bond here. That's 2, remaining 2 hydrogens and that same bond. And then for this one, it has just 1 bonding to this carbon, so it has 3 hydrogens to complete 4. So carbon has to have 4 bonds going on. Okay, now that we are done, the next thing we need to confirm is if this name is correct. Okay, because here they said rename where applicable, so we need to confirm that. If we are to count from here, we have 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 carbons. Now let's confirm if that's the longest chain. If we count from here, 1, 2, 3, 4, 5, 6, 7, or the other way, 6, 7, gives you the same, right? Now let's count again. Have 1, 2, 3, 4, 5, 6. This is lesser than 7, so we're not going to consider that. What if we count from here? 1, 2, 3, 4, 5, 6. Still less. So the next thing remaining will be from this order. So let's count from here. I have 1, 2, 3, 4, 5, 6, 7, 8. So that is the longest chain. And because we are then considering this chain as the longest chain, it means that this one's here. This one's here is the substituent, and this one. Why this one is the longest chain. Okay, so with that we have 8 carbon, and that shows us that this is octane, right? So at 1, 2, 3, 4, 5, 6, 7, 8, at the 4th carbon there is this group attached that has 1, 2, 3, 4. 4 carbons means a butyl, butyl. But then, what type of butyl is this? This is called tertiary butyl because it has no hydrogen attached to this central carbon. Okay, and we abbreviate it as TAT. So we start by saying 4 TAT butyl. Then at the fifth carbon we have 5, and this is obviously ethyl octane. Okay, so that is the name for this compound. It is not this. So this is wrong, and this one here is the right one. Okay, so you have 4 tat butyl 5 ethyl octane. All right, so for this one, this is your longest chain. So you have a 1, 2, 3, 4, 5, 6. Hairs represents 6 carbons. Now on the second, you have a propyl, which is CH2, CH2, CH3. Now let's do the same thing we did over here. This we have 3 carbons, plus this we have 4, plus this 1, 2, and another bond here. So we have H here. Now you have another bond here. You need 2 hydrogens, so you put the 2 hydrogens. This has 1 bond and 1 bond at this end. You need 2 hydrogens, you put the 2 hydrogens. This has 1 bond, 1 bond this way, also 2 hydrogens. This needs 3 because it has just 1 bond. Okay, so now all the bonds are complete. Each of these carbons have 4 bonds now. The next thing we need to now think about is this name correct? Is the longest chain here hexane? Is it 6? Now let's check out. So I have 1, 2, 3, 4, 5. It's not up to 6. 1, 2, 3, 4, 5, 6 is 6. And then there's this other one that we can count from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, or 1, 2, 3, 4, 5, 6, 7, 8. So 8 is our longest chain. So you have octane as a parent. So if we are considering this part as the longest chain, it then means that this is the attachment, right? So now that we know the attached group, we have to number it in order to make sure that this place is given lower number. Okay, so we'll number from this end. 4, 5, 6, 7, 8. So this is attached on the 4th carbon. So the name will be 4-methyl octane. And this is the correct name, why this is wrong. Okay. Okay, so for this one, we're asked to draw the line structures of the following. The A is 3-ethyl 4-methyl heptane. And as usual, we're going to consider this root here. Now, this is telling us there are 7 carbons. And in line structure, you start by putting down a dot. And now your dot is part of your carbon. That is your carbon 1. Okay? So you start to say 1, 2, 3, 4, 5, 6, and 7. So now that we have our 7 carbon, you can confirm this is 1, 2, 3, 4, 5, 6, 7. So now you have your 7 carbons in a line form. Now on the 3rd carbon, there's an ethyl group, and this is 1, 2, 3. So this is your 3rd carbon. So you put your ethyl group. Now note that this is how you represent ethyl in line structure. If you count it, you have 1, 2. Okay, that end is just the bond with the main parent chain. So this is 1, 2. Okay, on the 4th carbon, you have a methyl group, A methyl group is represented by just this. When you count this, you see this is just one. Okay. Why, if you are dealing with propyl, you have something like this. So propyl group would have, say, let's say this is the parent chain. Okay. So this is how it's going to come out if this was a propyl group you are dealing with. Okay. All right, so we have our compound here. So this is it. 1, 2, 3. At the third carbon, you have an ethyl group. At the fourth carbon, you have a methyl group, and the parent chain is 7 carbons, which is heptene. For this one, you have 4-ethyl, 5,5-dimethyl decane. Now this represents 10 carbon chain, and we'll start counting again from your dots: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now on the fourth carbon, you have a T group. So you have 1, 2, 3, 4. So here you have your ethyl group. Okay. And on the fifth carbon, you have 2 methyl groups. So that would be 1 and then 2. This is your fifth carbon. So here you have it, the line structure for 4-ethyl, 5,5-dimethyl decane. Thank you for watching. If this video has helped you in any way, please subscribe, like, and comment.